So I'm going to do a quick run through the basic functionality of the Nucleus tools in Vasari. And to start, you need to be in a family. It doesn't work in the project environment, only in the mass RFT environment or RFA environment. And you access the tools through the Nucleus toolbar over here in the corner. Let me get the ribbon down here. There it is. And you basically need to start at the left and move over to the right. It's a pretty finicky workflow, but once you get the hang of it, it works pretty well. So you start off by creating a surface, and I'm just going to put this, it goes down on whatever the active level is. So I'm just going to drop one down here, right on level 1. And what it's going to do is it's going to create a grid of points, 10 by 10, and you can change these defaults before you place it down, and it'll come out as different sizes. So actually, if I undo that, you can go and you can do like a 5 by 10 and make this different sizes. And then if you create your slice, you go down and pick it, and you can see that it comes out at a different size. But I'm going to go back and do the default settings, which is 10 by 10 and at a 200-foot grid, like that. I'm going to create my surface, and it just drops it down there onto level 1. And then the thing that you need to do right after that is to select the whole surface, and if you hover over it and you go tab, then you're selecting the whole surface. And then you need to click back to Nucleus, and then you need to assign a material to it. It doesn't really behave until you do that. So if you go in and you assign, let's do rubber, then this material is going to behave with properties similar to that of rubber. And now what I'm going to do is, this is going to be just one workflow where I go in and basically make it act like a sort of a napkin acting under gravity. And what I want to do is I want to constrain this thing so that all of these pieces aren't flying all over the place. If I just activated the simulation now, this piece of material would just go flying off the screen. So what I want to do is I want to tie it down, basically. Now I've just selected, I'll select 2 points, like that. And I'm also going to select, by going tab select, I'm going to select one of those lines. So now I've got a point, and a line selected. If I go back over to the Nucleus tab, I can add a constraint, and you're going to see the locks show up. And what that means is that I've sort of tied that point and this line down so that they're not going to move anywhere when I start activating my simulation. Right now I basically have enough that I can just hit go and we can run off and have our simulation. But I'm going to change a couple more things. I'm not going to add a collider right now, but a collider is basically an object that this surface would interact with and would basically bounce off of it or that sort of thing. But we're not going to do that right now. And I'm going to look at gravity. Right now gravity is going down, as you might usually expect gravity to go. I'm going to turn that around. I'm going to go gravity up, which is basically going to just, like it says, it's going to reverse the forces of gravity. And I'm also going to crank up a little bit about how strong gravity is. 9.8 is just some default. I'm not quite sure what it means. I'm just going to call that enough information that I've added to do my simulation, and I'm going to press simulate. And what this is going to do is it's going to start calculating a material like rubber being pushed up with this somewhat obscure amount of gravity, but you can see the calculations are happening here, and it's trying to sort of find an equilibrium point as it pushes up and tries to find a balance where it's being held down by these 3 constraints and being pushed up with this gravity system. Now, one thing that I don't really understand in this is why it's not symmetrical. I would expect if something had a symmetrical load coming up and it was basically symmetrically constrained that it would be symmetrical. It isn't. I'm not exactly sure why that is, but anyway, my simulation is starting to make less and less changes here, and I can see that it's basically getting this sort of somewhat stable form, and the simulation keeps going, but I can see that it's basically not moving much anymore. So I can stop the simulation, and now I have my points back here, and I can see basically that form that I just had, and I can inspect it and say, okay, this is an interesting looking form, and simply this is a form that is based on physical properties of a material in interaction with a gravitational force or an even loading. But I want to have something that's a little bit taller maybe. So I can go back in here, and what I'm going to need to do is, if I want to re-simulate this, I need to get that material back and change what its material properties is, or I can go and change how much gravity is being pushed on it. So if I want to change the material properties, I'm going to go over here to update to surface, and that's going to recreate that surface again. And if I tab select into it, I can go in here and I can let's make a new material, and I'm going to take rubber as the starting point, and I'm going to make it let's see, I'll make it have less friction, let's say. Not exactly sure what that's going to do. And I can go save, and then it will prompt me to save as a new material or keep the old one. I'm going to keep the current material and save as a new thing. I'm going to call it new rubber. Not a very interesting name, but that's what I got. And I'm going to close. And so now, just to make sure that I've assigned that, I'm going to select the surface and go to new rubber. And I'm going to rerun my simulation. We'll see if that's changed it in sort of an interesting way. The nice thing is that while the simulation is going on, I can look around at it too. And it looks like it's not getting much taller with that change that I've done. So I'm going to stop the simulation. And I'm just going to crank up my gravity so that it's pulling upwards even stronger. Let's give it 100 just for giggles. See what it does. So now it's going to really push it way up, because there's a lot more force coming upwards on it, and it's going to move around and find a sort of equilibrium point. And I'll just call that enough. There's not a lot of iterations here that have gone on in this calculation, but let's say that that's enough for now. So now I've got this surface. Now the problem is, if I go to update to surface, the way that this surface is created is I have many faces like that. And one of the things that I'm going to want to do is, I might want to do a divided surface on this. And if I want to do a divided surface, I don't want to have a whole bunch of surfaces. I want to have one surface that goes through the whole thing. So I'm just going to undo one step and get rid of that update surface. And I'm going to look at this thing right here, right in the side. I'm going to select one row of lines, and I'm going to make them reference lines. And then I'm actually going to make a surface, which looks a lot like what we had before, but this is actually one continuous surface, which means that I can take it and I can divide it. And then I can go and I can host panels in it or whatnot. I'm just going to undo back 2 steps for a second. So we're back here to where we've got our reference lines. The other thing that I can do is I can select a couple more of these lines. I'm going to make one more reference line, and I can start doing things like I can run a profile along there, so I can go set the work plane at that point, and I can make a circle, and I'll go like that, and so I can get sort of a mullion along there like that guy. And then I'll go back in and I'll make my surface again, create my form, and I can actually, even at this point, I can go back in and I can still do some manipulations, like say I don't want to have my new rubber, say I want to have let's make it out of silk. Oops, right. What I actually need to do is I need to update the surface. So now I have 2 surfaces here. If I tab into that, I think I've got my nucleus surface. And the nucleus surface I can now set to silk. And let's try the simulation now. Now I'm going to see that smooth surface that I created being simulated right along with the rest of the grid, and even my mullion moving with it. Now if I add more and more complex geometry, it just means that my simulation frames are going to go a little bit slower each time, because it also has to calculate all of this geometry that I've put onto the material. So I can stop and I can go back and I can say, crank up my gravity even more, whatnot. It's going to reset the simulation. Oop. I'm not sure why that. Oh, there we go. wasn't able to create the form for a moment there, but so now I've got my form sort of jiggling all over the place, and it'll run for a little while before it finds its equilibrium point. I'm going to pause my video for a second, and let's say that that's about enough. We'll go stop. So I've got my surface. I can hide those points that have shown up here by just going to hide points. Just cleans up the model a little bit so I can see it, and then I can do whatever I want with it, with like adding a divided surface. So I can pattern it. Let's give it a checkerboard pattern, and you can see you've got now this interesting shape. It's constrained, and it's real Revit geometry that you can play with and mess around with, and add things like curtain panel systems to it, or you can load this into a project environment in regular Revit, and you can do things like wall by faces and other by face elements on this, and have a ball. Anyway, so this is one kind of workflow, and I'll do another couple of videos that have things like colliders in it too.